Now, you see here, this is your xy plane. You know, x-axis, y-axis, যেতବେଳେ দুইটা থাকে তার কোনটি xy plane. This is the plus parts. This is your minus plus, and this part, this you take it as x dash. This will be minus, and this will be y dash, and this is your plus minus. Okay, so in case of your x and y value, you will take this xy plane. But in case of complex number, how can we plot the numbers on a plane? আমি complex number যেতବେଳେ নবা সেতବେଳେ তাকু কেমিতি রখিবা বর্তমান দেখ suppose 2 plus 3i. Suppose this is your 2 plus 3i. In this case, you can see here your real part is 2 and imaginary part is 3. So this is your x plus iy. So here x is equal to how much? 2. Y is equal to 3. So if you write in coordinate system, so this will be xy is equal to 2, 3. বুঝি পারলে না এটি তোমার x কোঅর্ডিনেট হচ্ছে কেতে 2, y কোঅর্ডিনেট হচ্ছে কেতে 3. কিন্তু এই যে কমপ্লেক্স নম্বর লেখা হয়েছে আকু তুমি কেমিতি যে 2, 3 কু প্লট করিব. So there is no other plane, there is no complex plane, but when we write a complex number in xy plane or on xy plane, then that plane will be a complex plane, or you can say it as Argand plane. So according to the mathematician Argand, this is your Argand plane. Understand that? So যেতବେଳେ তুমি কমপ্লেক্স নম্বর কো গোটে xy প্লেন উপরে প্লট করিব সেতବେଳେ তাকে কোয়া কোন that number when is plotted on xy plane, that plane will be called as complex plane. Complex plane বলি কিছু নথায় যেতବେଳେ কমপ্লেক্স নম্বর কো xy প্লেনে লেখা যায় তাকে কোয়া যাব কোন complex plane. So we can plot, suppose this is your x plus iy. Suppose this is your x plus iy. So here you see that this is your x from origin to this is your x and this is your y. Then this will be x plus iy. So now if I join this, suppose this is the point P. So now you see that OP is the hypotenuse of the right angle triangle OAP. OAP সমকোণী ত্রিভুজের OP হচ্ছে কোন কর্ণ ଆଉ OA ভূমি AP উচ্চতা তাহলে এটা কেতে হবে OP x স্কয়ার প্লাস y square root over. You know that OP square is equal to OA square plus OAP square. So this is your OA square is x square, AP square is y square. So what will be your OP? This will be your root over of x square plus y square. This is the value of OP. So this is taken as mod z. So if z is a complex number, so if z is equal to x plus iy is a complex number, then you can write mod z as x square plus y square root over. Okay, this is the modulus of z. Now I am going to conjugate of z. So look here, when you take z is equal to x plus iy, so you see that this is your x and this is your y. And if you draw this, suppose this is your A, this is your P, and this is your P dash, and AP is equal to AP dash. তাহলে যদি এইটা is equal to এইটা হয়, তাহলে এটা y হলে এটা কত হবে? This will be how much? Minus y. So if this is your x, this is your y, so this will be minus y. So what will be the coordinate of P dash? This will be x minus iy. Understand that? এইটু এদিকে আমি y হলে বা এইদিকে x এইদিকে y হলে this will be x plus iy. যেতବେଳେ আমি তলକୁ ଗୋଟେ ভ্যালু নবা সমান ভ্যালু এইটু এদিকে যেতিকি এইটু এদিকে সেতিকি, যদি এইটা y হলা এটা নিশ্চিত হবে কত হবে? মাইনাস y. তাহলে এইটু এদিকে হলা x, এইটু এদিকে হলা মাইনাস y. So this coordinate will be x minus iy. So if this is your modulus of z. Next, your conjugate of z. This is denoted as z bar. Understand that? Conjugate of z, this is denoted as z bar. So if z is equal to x plus iy is a complex number, then z conjugate is x minus iy. So this is your z conjugate. So now you see here, if z is a complex number which is denoted as x plus iy, then mod z is x square plus y square root over, and conjugate of z is x minus iy root over. Now we will prove some properties of conjugate and the relation between conjugate and modulus. So first one, we have to show z conjugate is equal to modulus of z square. Second one, z1 plus z2 whole conjugate is equal to z1 conjugate plus z2 conjugate. z1 minus z2 whole conjugate is equal to z1 conjugate minus z2 conjugate. Then z1 into z2 whole conjugate is equal to z1 conjugate into z2 conjugate. And the fifth one is z1 by z2 whole conjugate is equal to z1 conjugate divided by z2 conjugates. So we'll prove this 5 things about your conjugate and modulus of a complex number. complex number conjugate और modulus को नहीं जहाँ relation हबो हमें देखो बाहर करेगा. So first one, Z conjugate. So I am keeping here. Now you just look the problems and look the proofs. So now number one, LHS. Let Z is equal to X plus IY. So what we need in LHS and RHS? In LHS, Z conjugate is there. So what will be Z conjugate? This will be X minus IY. And what will be mod Z? This will be root over of X square plus Y square. Now you come to the LHS. Your LHS is equal to Z conjugate. So what is your Z? This is your X plus IY. And what is your Z conjugate? This is your X minus IY. So this is your A plus B into A minus B. So this value is A square minus B square. So this can be written as X square minus I square Y square. So this is your X square minus 1 into Y square. So the value is X square plus Y square. Now I can write it as X square plus Y square root over whole square. The square root of X square plus Y square and A square. So what is X square plus Y square root? This is your mod Z. So this is your mod Z square. So Z conjugate is equal to mod Z square. This is your proof. Okay. Now we go to second, third, fourth and fifth question. You can see here that in 4 questions there are Z1 and Z2. That means there are 2 complex numbers, which is one is your Z1 and other is your Z2. Okay. So let Z1 is equal to A plus IB. As imaginary number is present, I can write in terms of X plus IY. So Z1 will be one complex number and Z2 is the other complex number, which is C plus ID. Okay. So now we'll go to LHS. Or you can see here what is Z1 conjugate. This is your A minus IB. What is Z2 conjugate? This is your C minus ID. What is Z1 plus Z2? This is your A plus IB plus C plus ID. So now real part plus real part is your A plus C plus I, taking I common, this is B plus D. This is your Z1 plus Z2. Now I am coming to your LHS. So what is your LHS? This is your Z1 plus Z2 conjugate. So this is your A plus C plus I into B plus D whole conjugate. So look here, when you are taking the conjugate, your plus will be minus. So here you see real part plus imaginary part. So here the plus will be minus. This will be A plus C minus I into B plus D. This is your LHS. Now we'll come to the RHS. So what is RHS? RHS is your Z1 conjugate plus Z2 conjugate. So what is your Z1 conjugate? Z1 conjugate is A minus IB. And what is your Z2 conjugate? This is your C minus ID. So you know that in case of complex number, you have to write all the real parts together and the imaginary parts together. So here, this is a real part, there is no I. This is also a real part, there is no I. So you have to collect all the real parts. So collecting the real parts, this will be A plus C minus, taking I common, this will be B plus D. So IB is an imaginary number, ID is also an imaginary numbers. So collecting the imaginary numbers, this will be I into B plus D. Now look here, LHS is equal to this and RHS is equal to this. Therefore, LHS is equal to RHS. Now we will go to question number 3. In question number 3, we need Z1 minus Z2. So what will be Z1 minus Z2? This will be A plus IB minus Z2 is C plus ID. So this is your A plus IB minus C minus ID. So this implies Z1 minus Z2 is equal to A minus C plus I into B minus D. This is your Z1 minus Z2. So we will find its conjugate. So this implies LHS is equal to, now we will write here, LHS is equal to Z1 minus Z2 whole conjugate. This is equal to A minus C plus I into B minus D whole conjugate. Now you look here, when we have to calculate the conjugates of a complex number, so plus will be minus, so this will be A minus C minus I into B minus D. So this is your LHS. Now we will come to the RHS. So RHS is Z1 conjugate minus Z2 conjugate. So RHS is equal to Z1 conjugate minus Z2 conjugate. So what is your Z1 conjugate? This is your A minus IB minus, what is your Z2 conjugate? This is your C minus ID. So now this can be written as A minus IB minus C plus ID. Okay, so collecting the real terms, this will be A minus C minus IB plus ID. So A minus C, taking minus I common, this will be B and the plus will be minus D. So it is your A minus C minus I into B minus D. So look here, this is your LHS and this is your RHS. They are equal, therefore LHS is equal to RHS, hence this is put. Okay, now we'll go to question number 4. Your question number 4 is the product of two complex numbers and its conjugates. Okay, so LHS is the product of two conjugate numbers, RHS is the product of two each conjugate numbers. Okay, now we will find Z1 Z2 for question number 4. Z1 into Z2, this is equal to A plus IB into C plus ID. So this is your AC plus IAD plus IBC plus I square BD. So AC plus I into AD plus BC plus I square in minus 1 into BD. So this is your AC minus BD plus I into AD plus BC. This is your Z1 Z2, product of Z1 Z2. Now what will be its conjugate? This conjugate will be, this is your LHS, okay? So LHS is equal to this, is equal to conjugate of this is AC minus BD plus will be minus I into AD plus BC. This is your LHS. Now we will go to RHS. RHS is equal to how much? This is your Z1 conjugate into Z2 conjugate. So what is your Z1 conjugate? This is your A minus IB. And what is your Z2 conjugate? Look there. This is your C minus IB. So multiplying this will be AC minus IAB minus IBC plus I square BD. So minus minus plus I square BD. So you know that I square is equal to minus 1. In the previous classes we have discussed I square is equal to how much? Minus 1. So putting here, this will be AC minus IAB minus IBC minus BD. So I square is equal to how much? Minus 1. So collecting the real and imaginary terms, this will be AC minus BD minus I into AD plus BC. If you compare the LHS here, so you will see that RHS is equal to LHS. Okay, so question number 4 is proved. Now we'll go to question number 5. This is your Z1 by Z2 whole conjugate is equal to conjugate of Z1 divided by conjugate of Z2. So now we'll go to question number 5. Z1 by Z2. So what will be Z1 by Z2? This is your A plus IB divided by C plus ID. In the previous class we have also discussed that in the denominator if you will find I tall, then this is an irrational number. I is equal to how much? This is equal to square root of minus 1. So if an irrational number is present in the denominator, what we have to do? We have to rationalize it. That means C plus ID is here. We have to multiply its conjugate C minus ID both in numerator and denominator. Understand or not? ଯେତେବେଳେ ତୁମର ଅପରିମେୟ ସଂଖ୍ୟା ହରରେ ଥିବ ସେତେବେଳେ ତାକୁ ପରିମେୟ ରୂପରେ ପ୍ରକାଶ କରିବାକୁ ହେଲେ ଯାହା ଥିବ ତାର କଞ୍ଜୁଗେଟ ଉପରେ ତଳେ ଗୁଣିଦେବ। ଆଗ ଗୁଣିଲେ କେତେ ହେଉଛି ତୁମର A into C minus I into AD plus I into BC minus I square BD divided by C square minus ID square. So this is your AC minus IAD plus IBC minus 1 into BD divided by C square minus I square D square. So this is your AC plus I into BC minus AD. I have collected the imaginary terms plus BD. Your I square is minus 1. So AC, A into ID, I into BC, I square minus I square is minus 1 divided by C square minus, this is your minus 1, so this will be plus D square. So what will be Z1 by Z2? This is your AC plus BD plus I into BC minus AD divided by C square plus this square. This is your Z1 by Z2. So if I take its conjugate, so what is your LHS? This is your Z1 by Z2. I can write it as x plus I by form, AC plus BT by C square plus D square plus I into BC minus AD by C square plus D square. So when I write its conjugate, Z1 by Z2 whole conjugate, this will be AC plus BT divided by C square plus D square minus I into BC minus AB by C square plus D square. This is your LHS. Now we'll go to RHS. RHS is equal to how much? This is your Z1 conjugate divided by Z2 conjugate. So what is your Z1 conjugate? A minus IB. What is your Z2 conjugate? C minus ID. If I multiply C plus ID both in numerator and denominator, this will be C plus ID into C minus ID. So it is, and this I is present, so you have to rationalize it, so you have to multiply it. So multiplying this will be AC plus IAB minus IBC minus I square BD divided by C square minus ID square. बुझी पाला नहीं? वर्तमान सबू गुणा वाला ऊपर तक और तक कौन बोला? A plus B into A minus B formula. So this is Z1 conjugate by Z2 conjugate. So this is equal to AC. So I square is minus 1. So this will be plus AC plus BD plus I into AD minus BC divided by I square into minus 1. This can be written as I square D square. So minus 1 into D square minus minus will be plus. This will be C square plus D square. So dividing it, this will be AC plus BD divided by C square plus D square. So look here, in LHS minus is there. I am taking minus common here. I into BC minus AD by C square plus D square, which is your RH or RHS. So in this way you can prove the conjugate numbers. So in the next class we will discuss about the square root of a complex number, how to find the square root of a complex number. Thank you.